Hello friends, welcome to Power Electronics. In previous class we have discussed the principle of operation of choppers. So what we have discussed, a chopper is a high speed on off semiconductor switch. It is connected from source to load or disconnect at very high speed. Third point we have discussed that Vs has the constant magnitude. The T on is the chopper on time. When the switch is on, the output voltage is equal to the supply voltage. During the off period, V output is equal to T on upon T into the supply voltage. That means it is the T on divided by T on plus T off, that is represented as T. So what we get at the output is equal to alpha times of supply voltage. Also here the T on means on time and T off means off time. So combine T is equal to T on plus T off, that means the chopping period. We have also discussed the duty cycle, which is alpha is equal to T on upon the T time period. Also, the load voltage can be controlled by varying the alpha duty cycle. So what we have, the output is equal to frequency into T on into the supply voltage. So today we will discuss the control strategies. So what are the strategies here? So we know that the average value of the output V naught can be controlled by the alpha, that means the duty cycle, by opening and closing the semiconductor switch periodically. The various control strategies for the duty cycle alpha are, as you can see here, it is TRC, that means time ratio control, and also we have current limit control. So if we discuss the what is the TRC here, as by the name you have understood that it is time with ratio control. So in the time ratio control, that means the time ratio, that is T on, time ratio means T on upon T, as the duty ratio, or also known as duty cycle alpha. So this is realized in two different strategies known as constant frequency. This is known as the constant frequency and the variable frequency. So what is there in the constant frequency system? In constant frequency system, the on time T on, that means this period T on, is varied by the chopping frequency is kept on constant. So this T time period T, which is known as the chopping frequency, also T is kept as constant, and T on here is varied. Variation of T means adjustment of pulse width. As such scheme is known as pulse width modulation. So what we called it as a pulse width modulation. Again I will repeat this. The time period T or the chopping frequency is kept as a constant and T on is varied. So we call this as pulse width modulation. Also here the T time period is constant, and also the T on can be changed. So T on somewhere is like that 1/4 of the T time period. That means it is the 1/4 means that it is a 25%. So alpha is equal to 25%. Also it is a 3/4 also. That means it is the 75%. Ideally alpha can vary from 0 to unity, but practically it is not possible. So next is the we called as the variable frequency system. So in the variable frequency system, what we have to change here, that the chopping frequency f is varied. So that means now this time period t or the chopping frequency is varied, and what we have to kept constant, two things we have to can be kept constant. What is that? T on can be kept constant, or either T off can be kept constant, but we can choose only one. Either we can vary the T on, or either we can vary the T off. This is known as variable frequency system, or also we called as frequency modulation scheme. So in this both the schemes, which of the scheme has a better result? So I will discuss this. Frequency modulation scheme has some disadvantage as compared to pulse width modulation. So we will discuss it one by one. The first point is the chopping frequency has to be varied over the wide range. Wide range for the control of the output voltage in the frequency modulation. So this is one of the disadvantage. So why? Because the filter design has to be wide. For the very wide frequency we need a large filter design. That is not possible. So second, what is the disadvantage is that for the control of the alpha, that is duty cycle, frequency variation would be wide. As such, there is a possibility of interference with lot of the other things like the signaling system, telephone line system in the frequency modulation scheme. Also, we have the large off time in the frequency modulation scheme may make the load current discontinuous, which is not desirable. If load current is discontinuous, that is of no use. So these are the disadvantages. So what we conclude from that pulse width modulation technique has some limitations, but the pulse width modulation scheme is better than the variable frequency scheme. So, but the pulse width modulation technique also have a limitation. In this technique, T on cannot be reduced to zero, as I have already discussed. It cannot be reduced to zero. It remains at some value for the most of the constant circuits used in the chopper. Such a low alpha control is not possible in the pulse width modulation. This also can be achieved by increasing the chopping period of the chopper. So we have understood this. Also, we also remember the difference